Hello Lander Math students. Today I'm going to give you a tutorial on solving both log and exponential equations. So these are not too hard. You do need a little bit of a prerequisite. Okay, so let's talk about the prerequisite that we need, the kind of one skill that we really need to have before we start solving log and exponential equations, and that is the definition of a log. Okay, so the definition of a log is it's kind of the inverse of an exponential. So if we have some base, let's say base b, and if we raise it to the x power, we get the value y. And if this is what we start with, then the definition of a log would be the log of that same base of y is equal to x. Now, I'm going to tell you how I have memorized this. What a log does is it gives you the exponent. You have to raise the base to in order to get the augment. Okay, so let's kind of take that piece by piece. The answer to a log is the exponent. You have to raise the base 2 in order to get the augment. Okay, so if b to the x is equal to y, then log base b of y is equal to x. Okay, so this is what we're going to use to solve our log equations. Now, I've got a log equation here, and I'm going to break this down step by step. I'm going to tell you why I'm making the choices that I'm making, and I'll also show you how to get this in your calculator. So it doesn't really matter if it's log or exponential equations. The steps are basically the same. And that first step is we need to isolate the log term. Okay, so in our example here, our log term is log base 4 of 2x plus 6. So that other thing that's next to our log is that coefficient of 4. So the first thing that we need to do is we need to divide that coefficient of 4 on both sides. So this is just using the properties of equality, good old-fashioned algebra, in order to isolate our log term. Okay, so if we take that step, our next step looks like log base 4 of 2x plus 6 is now equal to 1/2. Okay, so now that we have our log term isolated, the next step we need to take is we need to rewrite the function as an exponential. And when we do that, our variable kind of pops out into a place where it's easy to solve using regular algebra. So again, I remember this, the base of the log becomes the base of the exponent. So the base of my log is 4. So when I rewrite this as an exponent, the base of my exponent is 4. Now the answer to the log, in this case 1/2, that becomes my exponent. So on the left side of my equation, I'm going to have 4 to the 1/2 power. Now the other side becomes the augment, which is 2x plus 6. Now this looks like an equation that we've been solving for quite a long time, actually. So 4 to the 1/2 power, that simplifies to 2. And so now my last step is I just need to isolate for my variable. Okay, so let me get that written down here. So step 3, we're gonna isolate. Okay, this is just old algebra. Undo what's being done to the variable, and whatever you do to one side, you do to the other. So and you undo the operations in the opposite order that you would tend to use when you're evaluating expressions. So although on the right hand side I have multiplication and addition, usually you would evaluate the multiplication first and then you would do the addition, but since we're undoing them, we undo them backwards. So the first thing I'm going to do is I'm going to subtract 6 on both sides. 2 minus 6 is -4. And now we got to divide both sides by 2. And so we get x in this case is equal to -2. Now, of course, I can check that by putting it into your favorite calculator, whether it be a Desmos or a TI-84. Either one will work. So that's solving log equations. Let's take a peek at how this changes when we solve an exponential equation. So we've got an exponential equation down here. 9 raised to the x plus 10 power plus 2 is equal to 10. So I'm going to look at my steps again. So, but in this case, instead of isolating my log, I am going to isolate my exponential. So the exponential is the term that has the variable in the exponent. All right, so let's write down our steps here. So I'm going to isolate my exponential term. Okay, so that means in this particular case, I have to get rid of that 2 that's sitting next to my exponential. I want my exponent my exponential term all by itself on one side of the equation, and I want a constant on the other side of the equation. So I subtract by 2 on both sides. Okay, so if I subtract 2 on the left-hand side, I'll definitely want to do that on the right. The 2's cancel out on the left-hand side, and I'm left with 9 raised to the x plus 10 power. And on the right-hand side, I am left with 8. Okay, so now my second step is I need to rewrite as a log. Okay, so on the last example, if we were given a log, we would rewrite it as an exponent. Now our variable is in the exponent, and if we rewrite it as a log, our variable shows up in a place in the equation where it's really easy to solve. So again, I'm going to kind of walk through how I remember how to do this every single time. Okay, so the base of the exponent becomes the base of the log. All right, so in this case, the base of my exponent is 9. Okay, so I'm going to write log base 9. Let's see here, log base 9. Okay, so I've got the first step. Okay, now the answer to the log, so what is on the other side of the equal sign from my log is going to be the exponent. Well, my exponent here is x plus 10. So that x plus 10 is going to go on the other side of the equal sign. X plus 10. Okay, so now inside the log is the only remaining term. In this case, that would be 8. Okay, so I'm going to put 8 inside the parentheses. That is the augment of my log. So now this equation does not look too bad. Log base 9 of 8, that I can plug into a TI-84, or I can plug it into Desmos. Just because I'm recording this tutorial on my iPad, I will probably use Desmos, but either one works just fine. So now I'm on step 3, and I need to isolate from my variable. Okay, so whatever is being done to the variable, I gotta undo, and whatever I do on one side, I gotta do the other. So I'm gonna subtract 10, because that's the only thing that's next to my variable. Whatever I do on one side, I'm gonna do to the other. Now, a common mistake right now is often students will try to subtract that 10 from the augment that is inside the log. You can't do that. That's not okay, because log itself is a function. Okay, so the input into that log base 9 is 8. You have to subtract that 10 from the output. So in this case, my x is going to be all by itself on one side, and the precise solution would be log base 9 of 8, which we can evaluate, and we will do that here in a second. And we subtract 10 from that final answer. So if we need to get the approximate solution, that's when we go over to our favorite calculator. So let me see here. I can go to, and it doesn't matter, you can do Desmos graphing calculator or Desmos scientific calculator. Either one works just fine. In order to find it in the graphing calculator, we got to go to functions, and we got to scroll down to this button, log base A. So this was log base 9 of 8. Oh, let me see here. Of 8. And then we got to subtract 10 from that. Okay, so our answer is a negative 9.0536. In my class, if you go 4 decimal places, that's just fine. If you're out there in internet land finding these YouTube tutorials, other teachers may stress significant figures or those kinds of things a little bit more than myself at the level that I teach log and exponential functions. So you may have to round these in a different way, but I would accept a negative 9.0536. Negative 9.0536. Okay, x is equal to a negative 9.5036. Okay, let me make sure I got that right really quick. 0536, 0536. Oh, I did. I transposed a couple of those digits. 0536. There we go. Okay, so solving log and exponential equations really are not too difficult. You do need to know the definition of a logarithm, okay? Definition of a logarithm is shown right here. And those are two equivalent expressions, or they're how to write an exponential as an inverse, that is a log, and how to write a log as its inverse, which is an exponential. And doing so just kind of pops out the variable in a convenient way to be able to solve. So these are fairly standard level log and exponential equations. If you have any questions, feel free to give me a call or drop an email if you happen to be one of my students anyways. Otherwise, feel free to look out on other resources on the web. Hope you have a great day. This happens to be the second snow day in a month in my school district. So that's why you're seeing an increase in productivity on my YouTube channel today. That's how I'm keeping myself busy today. And I'm avoiding shoveling the 18 inches of snow we've gotten since last night. So hope you guys are staying warm, and I'll talk to you again some other time. Have a great day.